Hi, I'm Micah Woods, Chief Scientist at the Asian Turfgrass Center. This is another ATC Doublecut, where I take a second look at some of the content on the ATC website, on the ATC blog, and discuss some of the key points, giving it a second discussion, a second look, and a double cut. In this episode, I'm going to talk about organic matter accumulation, something that is perhaps not widely understood, but it seems to be a fact about how organic matter accumulates. And then I'm going to talk a little bit about how I prefer to collect samples for OM246 testing. The blog post that I'm referring to is about how organic matter accumulates, has a title of Organic material accumulates more rapidly in putting green soils under these two conditions. This is something that I base on research by Carley et al. From 2011. It's an article, I think, from Agronomy Journal. Dan Bowman is also an author. There's a lot of authors on this paper. And the article is called Soil Organic Matter Accumulation in Creeping Bentgrass Greens, a chrono sequence with implications for management and carbon sequestration. And what they did is they looked at creeping bentgrass greens in North Carolina, and they looked at how old the greens were. And then they measured the organic material, the organic matter content in the top inch, the top 2.5 centimeters. So this is kind of directly related to what we would think the OM2 would be. What I recommend doing is testing the top 2 centimeters, the 0 to 2 centimeter depth. They measured these in the top 2.5 centimeters, and I made some calculations based on their results. They measured the total organic material in the top inch, in the top 2.5 centimeters. And they knew that, for example, this sample is on a green that's 4 years old. This sample is on a green that's 21 years old. This sample is on a green that is 17 years old. And by doing that, they were able to find how the organic matter accumulates as greens age. And what they found, and I showed this in a chart in the blog post, they found that in the top inch, you can expect to have an organic matter of something around 4%, or a little bit more than 4%, as the green comes to be 5 years old. And by the time the green is 10 years old, it's up to a little bit more than 5%. And as the green comes to about 23, 24, 25 years old, you can expect in the top inch the organic material may be about 6%. And there's a number of things that we can derive from that, which is very interesting and not quite intuitive. But if you see that the younger greens have less organic matter, which is very clear, there also is a relative rapid accumulation of organic matter. You see, to go from a green that's 0 years old and has very low organic matter to a green that is already up to 4% organic matter, that only takes 4 or 5 years. We can get that first 4% of organic matter in only 4 or 5 years. But then to get an additional 2% of organic matter, to go from 4% organic matter up to 6% organic matter, it now takes an additional 18 or 19 years to get half as much. To go up from 4% to 6% is half as much as going from 0% to 4%. And remember, to go from 0% to 4% takes less than 5 years. To go from 4% organic matter up to 6% organic matter takes about 18 years. So the accumulation rate is changing. The rate at which the organic matter accumulates in the soil is very rapid when the greens are young and when the greens are relatively low in organic matter. And it's not really possible to separate whether that's a phenomenon of age alone or a phenomenon of low organic matter, baseline low organic matter content in the soil alone, or you just can't really separate that. But I would suspect it has to do with how much organic matter is in the soil, which is also, let's just say that and age are the same thing. They're very closely correlated. As we derive some things from this, we can see that the accumulation rate in the grass green top inch has an accumulation rate in year one of about 15 grams of organic matter per kilogram of soil per year, or that would be the same as seeing an increase of 1.5%. So you would, for example, you would go in year one, and let's say that the organic matter was at 1%. If the green is that age and has 1% organic matter, you could expect that in 1 year it may go all the way up to 2.5% because it would add an additional 15 grams of organic matter per kilogram, or go from 1% up to and go from 1% with an additional 1.5%. It then becomes 2.5% organic matter. That's the type of accumulation rate that you would have in a young putting green. But the green that is 10 years old has a accumulation rate that is less than 2. I mean, less than 0. So it's less than 2 grams per kilogram, or less than 0.2%. And by the time you get to greens that are 20 years old, 21 years old, 22 years old, they have a very, very low organic matter accumulation rate. It's close to 0. They don't change much year to year. Keep in mind, those greens that are 20, 21, 22 years old, they also have a relatively high organic matter content. They're different from the young greens. They're different from the greens that have a very low organic matter content. In the final chart, I then move away from years and just start looking at this on a starting organic matter content basis. And if we do that, this chart I called the net top inch organic material accumulation rate in bentgrass greens by the starting organic matter content. If we look at it this way, when the organic material in the top inch is at 2%, we can expect an accumulation rate of more than 15 grams per kilogram, or more than 1.5% per year. When we have so let's see, that's when we have 2% organic matter. If we have 4% organic matter, let's double the organic matter content and have it at 4%, which I'll tell you, in the top 2 centimeters, or the top inch of a sand-based creeping bentgrass root zone, that would be a pretty typical number to have. If that's the case, we can expect that the annual organic matter accumulation rate would be half what it was at a starting level of 2%. The organic matter accumulation rate, when you have a starting organic matter level in the root zone of 4%, the accumulation rate is expected to be about 8 grams of organic matter per kilogram per year. That is 8 grams of organic material per kilogram works out to be 0.8% on an absolute basis. These charts are not quite intuitive, I think. The charts themselves are intuitive. The charts are simple and easy to understand. I would encourage you to have a look at it and read this post, because the implications of all of this are kind of important if this is actually the case. And you may have an inkling of what those implications are. You may realize that what this implies is that the very process of reducing the organic matter in the soil, the very process of physically removing organic material by coring, or the process of diluting the organic matter in the soil by adding sand as top dressing will reduce it. It increases the mass of the soil and consequently reduces the organic matter content by weight. What this does is it moves the green into a slightly younger age. What would we say? Status, age, something like that. It makes the greens a little bit younger, and it makes the greens have less organic matter. So whether we're doing coring or doing sand top dressing, it's reducing the age of the greens in that zone where we're adding fresh sand. And this sounds like a great thing to do, but as we do that, keep in mind that that inherently causes an increase in the organic matter accumulation rate, because in those young soils, the younger the soil is, the less organic matter content there is in the soil, the more rapid we can expect the organic matter accumulation rate to be. This is something that is quite interesting, and it's tied in with what I talked about in the last episode of the ATC Doublecut, where I mentioned that it's interesting to consider where the organic matter goes. And I suggested in the last episode that maybe the organic matter was never there to begin with. In the cases where people are having great success in maintaining a consistent organic matter content in the soil over time, even though they're applying less sand and doing less core aerification than they used to. It may be that as they're doing that, they're able to maintain a slightly slower growth rate. And it may also be that their greens are not being flipped into this young state. They're not being flipped into this younger than natural state by removing cores, filling them with sand, by adding so much sand that the green ends up having a more rapid organic matter accumulation rate. It's interesting to think about. You can find out how this works at your facility by doing OM246 or total organic matter testing. And you can find out how the organic matter changes over time at your facility. It's something that I think is really interesting because it allows us to optimize the amount of sand top dressing and the amount of core removal that we need to do to achieve the desired results anywhere. It may be that you need to put more sand. It may be that you should do more core aerification, or it may be that you can get away with less. To do that, we need to look at a time series of organic matter content measurements by looking at that time series and looking also at how much organic matter management work was done over the interval between the testing events. We can calculate the organic matter accumulation rate. And as you look at what the site-specific organic matter accumulation rate is, it's possible to then move forward with some site-specific adjustments to make sure that you're applying enough sand and that you're doing enough organic matter removal, and that you're doing that organic matter removal and the sand injection or the sand additions at the proper depths. I haven't talked about this for a long time because I guess it seemed to be so consistent. But back in 2017, 2018, 2019, as I was doing some of the initial work with the OM246 test and looking at these results year after year, it was, at first, it was kind of interesting to note that once you go below the surface and start going down an inch or two, looking at something 2 to 4 centimeters below the surface, or 4 to 6 centimeters below the surface, or in inches, that would be something like 1 inch, 1.5 inch, 2 inches below the surface. The organic matter doesn't change very much. In fact, it, for all intents and purposes, it basically doesn't change. And we would think that it might be accumulating rather rapidly down there, but it's not. And then the question becomes, well, why would we need to pull a core to a depth of 3 inches, or something like 7.5 centimeters? Why would we need to pull a core, remove the organic matter, and put fresh sand to that depth if we have organic matter content in the soil remaining constant month after month, year after year at those deeper depths? That's also something that is interesting to look at. And now the next post I want to talk about is a quick one, my preferred method of OM246 sample collection. There's a lot of people who are doing OM246 testing this year. If you're one of those people and you've been corresponding with me about that, or if you've already seen your test results or seen your report, thank you for doing this testing. I think anybody who's doing it, whether you're doing it through ATC or doing it through many of the other people or labs that can offer this type of testing, I think that you will find this extremely useful. But sometimes the question comes up, how should I collect the samples? On the ATC website, and there's a link to this in the post, there's a link to the OM246 sampling instructions on the post. In the post, I have a 2-page document that describes how I recommend collecting these samples. And in that document, I suggest taking a stainless steel pipe that you would slightly sharpen the end, slightly sharpen one end of it, but don't taper it. Just sharpen the edge. You can then pound that pipe in, press the extracted core out, and cut it to depth. I like to do this with a 3 or 4 centimeter diameter pipe, and I have had great success with one that's 4 centimeters in diameter. In inches, this is going to be something about 1.25 to 1.5 inches, something like that. That's the depth of the sampler. In this post, so the post I'm talking about now is called My Preferred Method of OM246 Sample Collection. And I will put a direct link to this. All the posts that I'm talking about is the primary post here. I put a link in or the show notes. I was responding to a question that I received. A colleague wrote with this inquiry. Let's see. I know you use a pipe. Do you see any objection to using a soil profiler? We tried to use a solid pipe, but it was impossible to get the core out without damaging it. We went with the profiler instead. Thoughts? And I said, fine, I have used a profiler. No reason that won't work perfectly well. I showed a picture of the type of sample that comes from a profiler, and then I elaborated a little bit on why I prefer the cylindrical sampler, why I prefer the sampler that is a pipe. And there's really, I mean, there's only a couple things that you really wanted about. The one thing that you want to be concerned about is cutting at depth. And one of the reasons why I prefer a pipe that's 3 or 4 centimeters in diameter is I've found it easier to cut those at depth by hand because it's a smaller sample. And when I was taking samples with a soil profiler, I found it a little bit trickier to cut evenly across that entire depth, or across that entire sample, because the sample is larger. And to me, it was just easier to make a straight cut with a knife in a 3 or 4 centimeter diameter core than it was to cut through a soil profile. That's one reason. And the second reason why I recommend using a pipe is, as I've used so many different samplers, and a lot of standard soil samplers have a taper at the tip where as you push it into the soil, it's tapered, and that allows it to penetrate into the soil a little bit easier. But what happens as that is pressed into the soil with that taper, the sample comes through that tip and it comes into the cavity of the sampler, or the main body of the sampler, that now has a larger diameter than that tapered tip. And if you look at that, it seems to me that, at least in sand root zones, that often creates a sample that looks like it's been decompacted. It's like the sample expands a little bit. And I'm not sure that this has any effect on what the test results would be, but I always wonder, because I think, what if in that expansion, as the sample comes through the tapered tip, what if that is making the depth off by a millimeter or two? Which, again, if the depth is off by a millimeter or two in this sampling, the sampling is still quite robust to that amount of discrepancy in depth, and the results would be equivalent. But I prefer to cut through a sample that looks like it has not been decompacted and is closer to what I expect the soil bulk density to be. And that's why I like to use a pipe that I hammer into the soil, and that pipe does not have a tapered tip. With soil profilers, I've also found that they also tend to have not such a pronounced tapered tip, but they also sometimes have an angle where somehow where you're putting the profiler into the soil is a little bit smaller than the cavity in the profiler in which the soil profile actually sits. And I've been a little bit concerned, again, with that decompaction issue. So the two reasons why I have not been using a profiler are related to ease of cutting to depth, and are related to the sample being possibly decompacted or not. But if you're able to collect the sample and you're able to easily cut it to depth, and you're very comfortable that you're cutting at approximately the right depth, and if you're comfortable that the sample is not been decompacted as it's pulled from the soil to any substantial degree, then anything works. And I've collected these samples and gotten good results and reproducible results with a variety of samplers. And it's just that the way that I prefer to do it is using that pipe, which is something that I've gotten quite comfortable with using over the years. So that's a little bit about organic matter accumulation rate, and about the surprising effect of young greens, and the work that we do to create young greens. Maybe inadvertently, it's actually increasing the organic matter accumulation rate. So it would be something like chasing our tails to manage organic matter, when the very work that we do to reduce organic matter, what if that work is actually increasing the amount of organic matter that's in the soil through an increase in the accumulation rate? It's interesting to consider. It's something that can be checked by looking at OM246 test results over time. And I encourage everybody, if you're able to do that, please consider doing that testing, because it will give you a chance to figure out if you need to do more sand top dressing and core aerification and that type of organic matter management work, or if there would be an opportunity to do less, or if the work that you're doing right now is just right. I'll be back soon with plenty of more content here on the ATC Doublecut. For now, for ATC in Salem, I'm Micah Woods.